Hi guys, my name is Taurayi Raymond Sewera, and I'm from Zimbabwe in Africa, and I am AAC certified advanced level specialist in hybrid and electrical cars. I'm also ACDC certified master technician in hybrid and electrical cars. Master technician is a technician who is certified in every system that is on a vehicle. You talk brakes, it's a system on its own. Steering and suspension is a system on its own. HVAC, heating, ventilation, and air conditioning is a system on its own. If it has a transmission, it's a system on its own. So a master technician is a guy who's certified in every single system that's on a vehicle. So I'm ACDC certified master technician in hybrid and electrical cars. AAC doesn't have master technician status. It does have advanced level specialist in hybrid and electrical cars. He's the guy who does basically everything. He's a specialist who does every single thing that has got to do with hybrid and electrical cars. Today I'm talking about a full electric that I've taken apart for the sake of teaching others. Or, that's the way I taught myself to fix things. I used to tear things apart and kind of do my own reverse engineering to understand how things work. That's what I used to do prior to my professional training in the United States that I started in 2016. I will be showing you the components that I've removed, the high voltage component that I've already removed and what they do, and I'll try to explain as much as I can. But I will do further videos with different systems, because you can do one video if you want to talk about all the systems on an electric car or on a hybrid. So just talking about the major components, what they do, and the next videos I will actually be talking about one particular component and explore what it does and all that is involved for you to be working and how it works and that kind of stuff. So I hope you enjoy the next video that I'll be shooting, showing you all the components and all that kind of stuff. So yeah, I'm super excited to be able to change the automotive excellence here in Zimbabwe. That's the whole reason why I keep on coming back home. Even if I go overseas, I'm always thinking about I'm coming back and trying to change lives, because very soon I'll be opening an automotive technology training school here in Mandara, where I bought the land. So I'm super excited to be sharing this news, that Zimbabweans will be able to access the world-class training here in Zimbabwe. This is a Nissan Leaf 2011 full electric. So let me just show you what I've already done to it. I've torn apart most of the stuff, the high voltage components. I've already removed all that. Let me just show you in front there, in the hood, or as they say in the States, it's the hood. This is the hood. We say the bonnet, underneath the bonnet here in Zimbabwe or in Africa. So that's it. There's really nothing left here except this bed board here. This is your AC compressor. It's a screw type. It's a high voltage compressor. As you can see, everything orange is a high voltage. So don't worry about that, because I'm not wearing any protective equipment, because I have already disconnected the most dangerous part of the high voltage system, which is this guy, the cable they lead to that guy. Underneath there is a high voltage battery pack. It's a 400 volt lithium ion battery, and it's a 400 volts. Like I said, it is 192 cells, 48 modules. Each module's got 4 cells, 2 in series and 2 in parallel. So that's the battery you're talking about. So this guy, I'll talk about it when we get to the junction box or to the DC-DC converter, that I'll show you that I've already removed. So I think let's just go there and I'll show you the other stuff. So here we are. Let's hope there's enough light for you guys to see. Let me just run through all this. This is the stuff that I've already removed from the Nissan Leaf that we were talking about today. I'll tell you the names of the components one by one so that you might understand, or that might help you in any way if you own a Nissan Leaf, or you're a car enthusiast, or you're a professional technician and wanting to know the new phenomenon, the electric cars and hybrid stuff. This is the reason why I'm taking all these videos if I get the opportunity. But not many can have the opportunity of having a Leaf and tearing it apart or taking it apart. So I do, and love to do this stuff. The next time you see, I'll taking further apart this whole component, all these components I'm talking about. Today I'm just going to shoot a video about the major components and showing you how they work and what it is and what they are in the system. So basically this is the inverter, or you might say. So normally it will be like this when you open your hood or you open your bonnet. So like zero emission, so you open that guy. So look here, it's high voltage inside. Do not remove the cover and or connectors. Never, ever, unless you're highly trained, professionally trained hybrid electrical car technician. Okay, so we'll start with this guy there. This is your traction motor controller, like the ECU for the traction motor. If you're not aware of the traction motor, what the traction motor is, let me just show you what traction motor is. This is the traction motor. This is the electric motor, you might say. Okay, it's more like a motor generator, you know, in professional terms. Okay, we'll get back to the traction motor and talk about more on the traction motor itself. So this is a motor controller for the traction motor. Underneath it, there is the capacitors, 6 of them. This is solid state capacitors. And underneath the capacitors down there, there is the driver. The driver drives the power module. The power module consists of the 6 IGBTs down there. I'll talk more about that, how this whole system works. So we also have current sensors for the three outlets for the cable that goes to the traction motor. So like I said, we have current sensors for the 3 phases, because this is the AC that will be coming out from this port here to go into the traction motor. So let me just go back a little bit. We have the bigger cable that I just showed you from the car. That comes from the high voltage battery pack. It's a 24 kilowatt hour battery with 14 modules, 192 cells. It's a lithium ion battery. So it comes, that cable connects here. This is your junction box with a DC-DC converter inside as well. So this is the power coming from the battery pack, comes in through here. Then you can distribute high voltage from this thing here as a junction box, and inside it also works as a DC-DC converter. We talk about DC-DC converter, how it does its stuff. So when the power gets in there for the traction motor, it comes through here, this port here. This is still DC-DC high voltage, and it comes all the way, follow my hand, through here to the inverter. Then it connects here. Then the motor controller does its stuff. It sends a 12 volt pulse to the driver underneath there to drive the IGBTs. After it receives a signal from a resolver. The resolver is more like your conventional car crankshaft sensor. This is the guy here which will tell the controller the angle of the rotor inside, and it's spinning and all that kind of stuff. So when that information comes to the controller sends a 12 volt pulse to the driver, and the driver converts that 12 volt signal to 300 volt signal and drive the IGBTs. The IGBTs are integrated gate bipolar transistors. It is the phenomenon that was designed for us to be able to achieve all these electrical car and hybrid stuff, to be working properly, and to be doing what we're doing today, and to be able to achieve this technology. So the IGBTs, the transistors, the switches, solid state switches, no moving parts inside. So what it does is they switch so fast, like 1,000 times in 1 second. So they also generate a lot of heat, and they vibrate. I'll do a class or do a video just talking about the IGBTs, because there's a lot of stuff with the IGBTs. There was this gummy stuff that it's like some semi-liquid stuff that's around that's there in, so it depends the vibration that they create when they're switching on and off. So they also produce a lot of heat, hence the reason why we have all these coolant passages to cool the IGBTs underneath there. So we also have a smoothing condenser, which smooths the ripples are created by the IGBTs. As they switch on and off, they create ripples. If you know what I'm talking about, if you have known how the alternators work and that kind of stuff. So they switch on and off, so they create ripples. They need to be smoothened, with the condenser, the smoothing condenser. This is here. The white guy is a pre-charge. It's a pre-charge. No, it's a resistor. So we use this to discharge the capacitors. In any case there's a problem or that kind of stuff, or we've depowered, like I just done. So the capacitor will be charged, they need to be discharged. So you can use the resistor that way, or this system will discharge through the traction motor the other way. Okay, we'll talk about more. This is a lot of stuff to talk about. It's actually a day's thing to talk about. I'm just here to trying to show you the components and how they work and that kind of stuff. So here with the DC-DC converter, what I didn't mention is on an electric car we have a 12 volt system. We still have lights, we still have all that kind of stuff that uses 12 volt, and the 12 volts is also the system that switches on the high voltage system. So you need we have a conventional battery, more like a conventional battery, the 12 volt low voltage battery that's there under the hood. So it needs to be charged. So the DC-DC converter converts the 400 volts high voltage DC to lower 14 volts DC to charge the conventional battery. So that's that for the DC-DC converter. We'll open it some other time and show you what's in there and that kind of stuff. There's also IGBTs inside there. So we come to the traction motor. This is an 80 kilowatt internal permanent magnets synchronous motor. If you know what I'm talking about, this is a synchronous motor. I'll talk about more of that. There is induction motors and the synchronous motor, that kind of stuff. So there's asynchronous and there is synchronous motor. So we'll talk about that. Permanent magnets and induction motors. So these guys also generate a lot of heat. That's why we have this cooling system. So there's cooling system all around the stator. There's your shaft, there's your rotor, then the stator there. Then there is what I was talking about. It's more like your more like a speed sensor in a way, but not really. It does more of that. It does angle, it does speed, it does like all that kind of stuff. So it monitors all that kind of stuff. So next to it, this is supposed to be attached to that guy. This is more like your transmission, but it's called reduction box or reduction gear, in fact. Yeah, this is your park actuator, the black stuff there, because it's all electronics when you're changing your gears, when you put into drive or neutral or park and that kind of stuff. So it's all electronics. There is no moving parts or moving cables. So the other thing that we can lastly talk about is you need heat in the cabin, inside the car when it's cold. So there's no way we can generate heat because we don't have a conventional engine that can produce heat so that we can heat the water or the cooling system. Then we can have heat in the car. So they came up with an ingenious way of doing that. They came up with this PTC heater, positive temperature coefficient heater. It's a 5 kilowatt, 350 volts. That's high voltage thing with that guy. So this will produce or will generate heated coolant, I mean, say, to generate heat inside the vehicle, inside the cabin. Lastly, I didn't talk about this guy. This is your service disconnect plug. This is the guy you disconnect to split the high voltage battery pack into two. With the 12 volt system, looks for that. Then it sees an open here, does a switch on the high voltage system. That's one way to depower the high voltage system. So this is where there is a fuse inside here. It's a 450 DC fuse, 225 amps. It's just can see properly what you can see there. It's 450 volts, 225 amp fuse. Yeah, so I'll be shooting more and share with you guys electrical cars, how they work, the fundamentals, the components. I believe if you understand the fundamentals, you know how stuff works, you'll be able to fix them. Like my great friend in the States called Jim Martin always talk about, you gotta know your opponent. If you know your opponent, you'll be able to know, if it's boxing, you'll be able to fight them, and if it's soccer, you'll be able to know how to attack them and their weaknesses and all that kind of stuff. So in the car, in the automotive industry, you gotta know your opponent. You gotta know what the engineers are trying to achieve, why stuff are there with the car, and how you're gonna be able to diagnose them when they have a problem. So that'll be it for today, for this video, and I'll be shooting more, guys, and hopefully you learn one or two things from this. Yeah, adios, guys. No, before I go, I just want to say shout out to Fred van Bartenberg, ACDC owner, because these guys, they gave me an opportunity to go to the States as an intern to learn hybrid and electrical cars for 2 months. That's about 8 weeks. This guy is phenomenal. He's been just doing electrical cars and hybrid cars from 2000. I believe he's the best hybrid and electrical cars instructor on the planet, in my own opinion. So he's phenomenal. He's great. He's hilarious as well. So I mean, I'm a serious guy. He made me laugh. I'm always let's just go straight to business. And he told me, yeah, Taurayi, you miss the funny part of it if you keep on being serious and that kind of stuff. So I mean, try by all means. I don't want to waste a single hour, minute, just doing nothing, when I have the opportunity to learn. I'm aging. I'm 44 today, and I started going to a class, a normal class, just about 3 years ago. When I attended the biggest and best automotive training event of the planet called Vision IIATT training. Like you heard me talking about Jimon, Jimon is the guy that made me go to Vision IIATT training after I wrote him an email telling him my desire to become one of the greatest or one of the best automotive technicians. So he replied my email and said, Taurayi, it's unfortunate that you're from Africa, blah, 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 because he knew it was going to be very expensive for me to attend Vision IIATT training. But I told him, man, I'm in for it. I will do whatever it takes for me to attend this event. So he hooked me up to one of the most powerful women in the automotive industry called Sewera Hamilton. She's phenomenal. She's great. Then, to cut the long story short, they sent me emails, invitational emails or letters. Then in 2017, I attended my first training ever in my life. That was Vision IIATT training, the biggest and best automotive training event on the planet, period. If you want to be serious and you want to be great and phenomenal, as an automotive technician or as a manager or service writer in a shop or whatever, you gotta attend Vision IIATT training. There's no two ways about this. The training they offer there is out of the chart. It's off the chart. I mean, you can't get that in any books, in any written books out there, because they are phenomenal guys out there, incredibly talented guys out there that have written manuals on their own. They've figured out how to fix some stuff. They've designed some tools that can make the job easier, and they showcases that at Vision IIATT training, and see some of the stuff that you don't see in the textbook. So you gotta be there. And lastly, I just wanna shout out to AAC. I mean, this is all we have in automotive industry internationally. So I mean, this is standard. Everyone else should be AAC certified. If you're really serious automotive technician, you gotta be AAC certified. I can't emphasize much about that, but I mean, it's very important that you do that. When I started doing this stuff over 17 years, I was doing a lot of mistakes during all this long time. I don't know how many mistakes I made because I wasn't certified. AAC will certify you. When you're certified, you do the right thing, the right time, the right thing all the time. Because they ask you all the questions, the procedure, how to fix stuff and all that kind of stuff professionally, and the specs and that kind of stuff. They will be asking you all that. So I mean, it's a no-brainer. I mean, you gotta be there. You gotta do AACs. You gotta take your tests. If you're serious about what you do and you really want to take it to another level, or you would want to be responsible for killing some people because you didn't fix their car properly, or you didn't do the proper procedures to make sure these guys don't get involved in an accident or something like that. It's a serious thing that we do. Fixing cars is just it's a huge responsibility. Because motorists, they'll be having the whole family in the car, and they've taken the car to you to repair it or to maintain it so that they can drive safely, and you're not certified, and you don't want to be AAC certified or something like that. This is a reputable organization that tests us. That's just the level, the excellence level of automotive technology. So I mean, let's do this, guys, and I hope I can change a lot of minds about looking at the AACs and having certified and receiving training as well. Because the thing is, training, if you don't update, you evaporate. Because technology is changing every single minute, so you gotta step up. Otherwise, you'll be left behind. With this conventional thing that has been phased out, still, of course, you still have business to fix the ones that's there, but I mean, you gotta think further than that. You gotta think about the future. This is the future we're talking about. This is electrical cars. They're here. It's not something that from the movie or something that they will be coming. They are here. This is the 2011 vehicle we're talking about. That's 2011. That's about 9 years ago. Can you just imagine what's there for us in the next 2, 3, 4 years? I mean, something like that. Thank you guys for sticking with me.